Welcome back, guys. In the previous video we were looking at what simultaneous linear equations are, and I showed you an intuitive way of trying to solve what they are intuitively, and what I not necessarily did, but try to solve for an x and y value. This video is going to look at the algebraic side and what methods you need to use in order to solve two simultaneous linear equations. So when solving these simultaneous equations, there are two methods. One method is called substitution and the other one is called elimination. Substitution is easy, elimination is tricky. We don't have to look at the elimination process, it's not within a log sheet, but if you decide to do general maths units 1 and 2 in year 11, you will need to learn this, okay? The process of it is in this little flowchart here, which I'll get to in a second, but what we're going to be focusing on is the substitution method. So this chart here, we're going to have this help us determine what process we need to do and to use in order to solve the two examples here, okay? A lot of these rules, the rules that are in these peach colored boxes do seem a bit arbitrary or random if you don't understand what you need to do with them. So at any point, if you find a handy fact that you think is associated with one of these here, you're more than welcome to write on top of this, okay? So I'm not going to drill into this. I'm actually just going to go straight into the example, which I have here on the right hand side, and then tailor back here and then go from there, okay? So example 1, we're going to look at trying to solve the pair of simultaneous equations y equals x minus 1 and 3x plus 2y is equal to 8. Now, as habit, I always tend to write the equations one below each other. So the first one, y equals x minus 1, and the second one, 3x plus 2y is equal to 8. And then the second thing I do is, preferably in a different color, next to each one, I label them. I label them 1 and 2. And the reason why I do this is because I reference each equation based on just a number, so I don't have to keep writing this out, and you'll see what I mean in a second, okay? So before we get to this, there's going to be a pair of solutions, so an x value and a y value, that when I substitute into here will also be substituted into the second equation and be able to equal 8. These x values and y values have to be the same, okay? So hopefully this makes sense. I'm not going to show you the proof of why this works. We're just going to show you the skill set. So, do both equations begin with a y equals? Not necessarily. One of them does, yes, but the other one doesn't. Okay, so we're going to tailor through to no. Does one equation begin with a y equals? Yes, it does. One equation does have a y equals. So for this, we can go, we can go to the yes, and we end up with what we need to do. We're going to substitute y equals equation into the other equation and solve. What does this mean? In other words, see this y is equal to x minus 1. Do we see anywhere where there's a y in the second equation? Yeah, right here. This one right here, and I'm going to color this or circle this in yellow to show you that it's there. And what this fact is saying is anywhere I see a y within the second equation, I'm going to replace it with x minus 1 because y is equal to that based on this equation here. Okay, so anywhere I see a y, I'm going to replace it with this x minus 1. To put this into other words, I'm going to substitute. I'm just going to write sub. So I'm going to sub equation 1, into equation 2. whenever I see a y, I'm going to replace it with an x minus 1. And you'll see why I'm going to do this. So equation 2 is now going to look like 3x plus 2. I'm going to do an open bracket and put the x minus 1 close bracket is equal to 8. Okay? Do you see any y's within this equation now? No. You only see one variable. There's two of them, x here and x here, but there's only one letter that's the same, and that is the letter x. Okay? Now what we're going to do is algebraically tidy this up, and essentially we're going to solve for our x value. So the first thing we need to do is we need to expand that bracket, because 2 is on the outside of the bracket here. Remember the expanding rules that we did in the previous class? We're going to do that. Right, so the first part, 3x, still going to be the same. Plus 2, and x is being multiplied. So we're going to be writing 2x, because 2 times x is 2x. And 2, positive 2 times negative 1. Positive times a negative will give me a negative, and this will be negative 2. 2 times 1 is 2. And that here is equal to 8. Now, next step is we collect our like terms. There's an x and an x. They have something in common. They like each other. 3 lots of x's plus 2 lots of x's will give me 5x. Still have the minus 2. And this is equal to 8. Now, I want to get rid of that minus 2. The opposite of minus 2 is plus 2. So I'm going to add 2 to both sides. Minus 2 plus 2 equates to 0. We're trying to get rid of it in the first place. So we're left with 5x. And 8 plus 2 is equal to 10. 5 times some number gives me 10. That number has to be 2. Awesome. We have got our x value. Now, I can only imagine that a lot of you are looking into this. You can understand the processes that are going on from the skill sets that we learned from the previous class. But I can only imagine that you're just going, what is going on? What we have just done here is we've solved for one of the variables. Okay, we know that x equals to 2 works for this simultaneous equation. Okay, the only next thing we need to do is try to solve for y. So I'm going to just draw a little arrow code like that, just to indicate that I'm writing the next part here. And in order to do this, I'm going to substitute x equals 2 into equation 1. And you'll see why I'm going to do this. It will make sense. Equation 1, y is equal to, anywhere I see an x, I'm going to replace it with what I just solved, 2. I'm going to solve x equals 2 into there. So my y value is going to be 2 minus 1. 2 minus 1 is 1. So my y value is 1. Or my pair of solutions is 2, 1. We found the pair of solutions. We found the two numbers that when you substitute into both of these equations, they will be the same. Okay, so let's have a look. If I substitute x equals 2 into here, 2 minus 1 is it's going to give me 1. Obviously, we just worked that out, so that works. But more importantly, let's work this second equation out. What is 3 times x? What was it? x2. What is 3 times 2? That will give me 6. And what is 2 times 1? That will give me 2. And I'm adding those two numbers together. 6 plus 2 equals 8. Voila, it equals 8. So this pair works. It's the only pair that will work, okay? This is solving simultaneous equations, okay? Remember, at any point you can pause, write all of this down. I'm going to jump straight into the next example, okay? And this one, I'm going to go a bit faster because we've got about 5 minutes left. Again, I'm going to use this mind map just to help me out. Here we've got solve a pair of simultaneous equations. Y is equal to x plus 5, and y is also equal to minus 3x plus 9. You give me an x value that's the same. When I substitute that x value into both this one and this one, 1 and 2, it should give me the same y values. Alright, straight to the mind map. Do both equations begin with y equals? Well, in this case, yes. So we can actually just go straight to what it wants us to do. Make the equations equal to each other, excuse me, equal to each other, and then solve. Well, y is equal to x plus 5, and y is also equal to 3x plus 9. So this is just telling me that x plus 5, this here, is also equal to minus 3x plus 9. Because both of them are y, yeah? Meaning both of these here are equal to each other. They have to be the same, okay? And again, we've eliminated the letter y, and all we have left are just the letter x. Yes, there are 2 of them, but we can solve for this. So, we've got x's on both sides. How are we going to solve for this? I want to get rid of this minus 3x here. I don't like it on this side. So in order to get rid of it, I'm going to do the opposite, and I'm going to add 3 lots of x's. Okay? So minus 3x, I'm going to add 3x, and whatever I do to the right hand side, I've also got to do to the left. This right here gets cancelled out, turns into a 0. That's the whole point. We want to get rid of it. What we're left with on the right hand side is just a positive 9, or a 9. And 1 lots of x plus 3 lots of x's will give me 4x with that plus 5 tagging along. Next thing I want to do now, I've got just an x on the left hand side, which is good. There's a plus 5 associated with it, so I'm going to subtract 5 from both sides. That turns into a 0, because 5 minus 5 is 0, and I'm left with 4x on the left hand side. 9 minus 5 is 4, meaning x has to equal 1. And so 4 times 1 will give me 4. Alright, 2 minutes left. Let's see if we can answer this and not have a blunder of not being able to show you the answer. Alright, we're going to substitute x equals 1 into, and you can choose equation 1 or 2. The easy one, I'm going to choose equation 1. Substitute this into equation 1. Or in other words, y is equal to 1 plus 5, or y is equal to 6. So we've got a pair of solutions, 1 and 6. Let's see if this works. I substitute x equals 1 into here. 1 plus 5 is equal to 6, which is the y value. Obviously that works because we had to solve for it. Here's the important one. When x is equal to 1, let's substitute 1 into here. Minus 3 times 1 will give me minus 3, or negative 3. Negative 3 plus 9 will give me positive 6 for our y value here, which is what we got here. So this equation works. And that's a process of solving simultaneous equations. Yes, a bit confusing, a lot of steps, quite a long process, and a bit confusing if you don't have the algebraic awareness. But in saying that, practice, use this set of a mind map here to help you out. And hopefully the questions don't treat you too harshly. Check your log sheet to see which questions you need to do, and I will see you soon. Have fun, be kind, see you in either the next class or next video.